Alrighty, today we are going to be talking about volume of pyramids and cones. So finding the volumes of pyramids of cones. We have two new formulas for today that you're going to want to write down. So here we go. First one, volume of a pyramid. It's going to look similar to volume of a prism, okay? The only difference here is that this one has 1/3 in there. So it's 1/3, and then remember, capital B doesn't stand for base, it stands for area of the base. So you're going to be using a formula there, and you're going to be calculating something for the B. H is the height of the pyramid. Okay, what they have listed off to the side are these diagrams right here. If you take a look at them, this first diagram would be like our normal pyramid that we see. We would calculate the area of the base. The base is always going to be opposite of the point. Okay, so we would calculate the area of this piece here, take it times the height, and then you can either think divide by 3 or multiply by 1/3. This figure over here is what we call oblique, and we talked about that just a little bit last week. Oblique just means that the height isn't going to be directly over the center of the figure, but I would really calculate the volume the same way, 1/3 area of the base times the height. For a cone, we are going to use the 1/3. And remember, last week we talked about the shape of the base is going to be a circle. So how do I find the area of a circle? That's the pi r squared. So if I look at this formula here, it's 1/3 pi r squared times h. So really the same idea as what they have above. R is the radius of the base and h is the height of the cone. Off to the side, once again, they're showing us the example of an oblique cone, and that's just showing that the height can fall outside of the cone, or it's just not directly above that center point right there. That's what it means for it to be oblique, but we use the same formula. Okay, so walking through a few examples, this first one right here says, find the volume of the regular pyramid to the nearest tenth. Now, it does tell me that it's regular. Regular, once again, means that all of these sides will be the same on the base. Okay, so when I calculate the volume, we said 1/3 area of the base times the height. Okay, so I still want to see that area of the base that you're calculating this week. Since they told me it's regular and it's really a square there, I'm just going to take 10 times 10 and say the base is 100 units squared. The height of this figure is 8. So when I calculate the volume, I'm just going to go 1/3 area of the base times the height. Okay, and like I said, you can either multiply by 1/3, or I could take 100 times 8 and get my 800 divided by 3. I'm going to get approximately 266.66, so I would round it to 0.7 because it says nearest tenth, and we're just going to label this units cubed. Okay, now that was a very basic example. This next one, what I want to show you, it's asking us to find the volume once again. However, this time they're not actually giving me the height here. They're giving me what's called the slant height, and that would mean that like this triangle is slanting up to that top point. This right here is the slant height, and that would be like the height of the triangle. But remember, since it's slanted, it's not actually the same as the height of the pyramid. So what we do here is we create a right triangle. We connect here. Okay, so if I were to sketch out that right triangle for you, what I'm trying to find here is this is my height, this is the slant height. What am I going to use for this bottom piece? Well, it's really going from the center of the base to the edge. And I know that this full side was 14. So if I cut it in half, like the center to the edge, this would be 7 right here. Once again, what am I going to use to find the height? Pythagorean theorem. So we're going to say h squared plus 7 squared is equal to 25 squared. And as I work through here, if I take h squared plus 49 equal to 25 squared gives me 625, I believe. Yep. And from there, I would subtract the 49, and I would have h squared is equal to 576. And then my next step is to take the square root, and I'm going to find that h is equal to 24. Now, so what I found is that the height of this pyramid is 24, and now I can actually go about finding the volume. Okay, so volume, I'll do it in a different color. Volume, we said, is 1/3 area of the base times the height. Area of the base here, we're assuming it's regular once again. So the base is going to be a square, meaning that all of these sides are 14. So 14 times 14 gives me 196. The height of the pyramid, we just found it to be 24. So if I want to find the volume, I'm just going to go 1/3 times 196 times 24. So if I take, sorry about that, 196, I get 1,568, and I'm going to label this units cubed. Okay, moving right along. So we did an example just with the basic, with the height. This one had the slant height. We're going to take it one step further, and this time they're going to give me a piece which we would actually call the edge. Okay, so if I'm looking at this top pyramid, what they have labeled as 10 right here is not actually the slant height on that triangle. If I were to draw out that triangle for you, this is the 10 and this is the 10. This is where that slant height would be. Okay, so the slant height is not that piece that I just highlighted. It's the edge. Okay, so what I would do on a problem like this is I would actually connect the slant height, which I'm drawing in blue. I would connect it over to that edge. Okay, so if I draw this out, here is my new triangle. Okay, so this blue line right here is that slant height that I drew in. So I'm gonna say that usually for slant height, they use an L to represent slant height. So I'll put an L there. Okay, I know this side over here is 10, and I could find the bottom piece. Remember, it goes from the edge to the side. We're gonna assume that this piece is the same length as this piece here. So if I'm going halfway, I'm gonna get 6 right there. And now I can use that Pythagorean theorem. So here I'm gonna say L squared, which is my slant height, plus 6 squared is equal to 10 squared. Here I get L squared is equal to 36. L squared plus 36 is equal to 100. If I subtract the 36, I get L squared equal to 64. So my slant height is going to be 8. Now I can fill in 8 right here, and now I can actually go about finding the height of this pyramid. Okay, what am I going to use for this bottom piece? Once again, the full length here is 12. So if I go from this center to the edge, it's going to be 6. And once again, I'm just going to use Pythagorean theorem. So for this problem, I just needed to use the Pythagorean theorem twice. Here I get h squared plus 6 squared equal to 8 squared. So I get h squared plus 36 equal to 64. And if I take 64 and I subtract the 36, I end up with h squared equal to 28. And if I take the square root there, root 28 is going to be approximately 5.29. Okay, and that's what I'm going to use for my height then. My height, I'm just going to draw an arrow, 5.29. Okay, so if I want to find the volume of that pyramid from here, I'm going to switch colors. Volume, remember we said is 1/3 area of the base. Well, for the base of this one, I'm going to say it's 12 by 12, so 144 is the area of the base. The height we just found to be 5.29. So we're going to say it's approximately 253.9. This time I can label it millimeters cubed. And then what we need to do is we actually need to find the volume of the full figure, not just that pyramid. Okay, so if I think back to last week to find the volume of a prism, I take the area of the base times the height. Well, for this prism, the base is still going to be the same as what I had for the area of the base of the pyramid. So it's 144. We got that by taking 12 times 12. Now the height of this one is 12 as well. So if I take 144 times 12, I end up with 1,728 millimeters cubed. And for my final answer, I want to add these two values together. So for my final, if I take 1,728, add it to 253.9, I end up with 1,981.9 millimeters cubed, and that is my total area. Okay. All right, moving on to the cone now. So this figure right here is that cone. Find the volume of the cone to the nearest tenth. So what we're going to do here is it looks like we're missing the radius. So in order to find the volume of a cone, I go 1/3 pi r squared h. So I need to figure out what that radius is, okay? They give me this 70-degree angle. I want to find this side down here, okay? It's a right triangle. I'm going to use my trig functions. So from this angle, I label my side as opposite and adjacent. Can you guess which trig function we're going to use? We're going to use tangent. So tangent of 70 is equal to 25 over x. And when I cross multiply, I get x times the tangent of 70 equal to 25. And my goal is to get x on a side by itself, so then I need to divide by the tangent of 70, and I'm going to find x to be approximately, if I take 25 and divide by the tangent of 70, I end up with 9.099. So I'm going to round it to 9.1, and that's going to represent my radius. And now I can calculate the volume. 1/3 pi times 9.1 squared times the height, which is 25. So 1/3 times pi times 9.1 squared times 25. I ended up with 2,167.96. So I'm going to round it to 2,168, and I'm going to label it feet cubed. And there's my total volume. Okay, now just like we talked about earlier, I wanted to show you a couple more examples of that oblique. Here would be an oblique cone, just meaning that the point is not directly over the center of the cone. So the height is actually represented just off to the side. I still calculate using that 1/3 pi r squared times h. It doesn't change the formula at all. It's just going to look a little bit different. This would be another example. The height is actually located here, and it would be connected to the diameter there. This one I would actually use my Pythagorean theorem, and it would give me the diameter, and then if I wanted to find the volume, I would need to cut it in half to find the radius. Not going to make you do it right now, but just showing you some examples where of the oblique figures, where the height isn't directly above the face. A summary chart quick of what we talked about last week and what we talked about this week using volume. So this is just volumes of the solids, the prism, and then there's an example, and then it shows you the formula there. The cylinder is using that same idea. And then what we talked about today was the volume of the pyramid, volume of a cone. Remember, today the only thing that's changed is we're using that 1/3 in there because they're going to a point. Okay, assignment would be workbook page 157 and 158. And I want you to show B for every problem, just like you guys did last week. I would encourage you to spread this assignment out. Don't sit here and do it all at one time, but do one day, take a break, do 158 the next day. You guys are doing an awesome job. Keep up the great work. Email me if you have any questions. Bye.